Hi everyone, my name is Makumba Gerard of Edumath. In this video, we are going to be given the iterative formula and we shall be required to get the original equation or polynomial. But before we go into it, please subscribe to Edumath such that you can be notified of our new videos whenever we make them every day. Don't forget to get a book and a pen closer to you, even a calculator, because you are going to calculate. So let's get straight into it. So we are going to be given the iterative formula and we will be required to find the original equation which solves. Let's have here a guiding question. So this here is our guiding question, an iterative formula for solving the equation fx equal to 0. We don't know it at the moment. It is given by this. Then they are telling us to take the initial approximation as 2. We deduce the root of the equation to 3 decimal places. And later on we find the equation which is solved by the iterative formula. Okay, so let's get started. Now here it is very simple. We are given x naught is 2 and they need this to 3 decimal places, meaning that our maximum error is equal to half times 10 power negative 3, which is 0.0005. Then what is remaining? We know that small n here is 0, 1, 2, 3, and this continue. Then let's substitute there. When small n is equal to 0, we have started iterating. So when small n is equal to 0, put it here. We shall have to get x1 being equal to a third into bracket 2x naught power 3 plus 12 divided by x naught power 2. So we need to substitute in for our x naught, and please get your calculator closer to you because we are going to make use of it right at the moment. So we have x1 being equal to a third into bracket 2 times x naught power 3, but x naught is 2, so 2 power 3 plus 12 divided by 2 power 2. So let's compute, and when you compute x1 will be 2.3333. Let's check on the error before we proceed. Error is the magnitude of 2.333 minus 2, which gives us 0.3333, and this is greater than the maximum possible error that is required of us, 0.005. So this tells us that we must continue calculating or iterating. So we go for when n is equal to now 1. We started with 0. So when n is equal to 1, we substitute in the formula here, in the iteration here. Okay, so when n is 1, we shall have x2 being equal to a third into bracket 2x1 power 3 plus 12 divided by x1 power 2. Then we have x1. Now let's substitute. x2 will now be equal to a third into bracket 2 into bracket 2.3333 power 3 plus 12 divided by 2.3333 power 2. So here when you compute again on the calculator, x2 will be 2.2902. So this is our x2, and again we have to look for the error, magnitude of 2.2902 minus 2.3333 and magnitude 0.0431, still greater than the maximum possible error, which is 0.005. So that means we should continue. Now when n is equal to 2, we shall have here x3 being equal to a third into bracket 2x2 power 3 plus 12 divided by x2 power 2. But we have x2 here, so we can now confidently compute x3 into, let's substitute in for x2, we shall have this, and now when you press on our calculator there, we shall get x3 as 2.2894. Then we go ahead and get the error, which is the magnitude of x3 minus x2, 2.2894 minus 2.2902. So when you subtract there, we shall have to get 0.0008. Still, this is greater than the maximum possible error, which is 0.005, meaning we should continue. So when smaller n is equal to now 3, we shall have to get x4 being equal to third into bracket x3 to x3 power 3 plus 12 divided by x3 power 2. x3 is right there, so we shall have x4 as being equal to third into bracket 2 into x3, which is 2.894, 2.2894 this power 3 plus 12 divided by x3 squared, 2.2894 power 2. So when we compute again, x3 will give us 2.2894. You can see that it is the same value as x3. So for this case, when you get x4 minus x3, the error is going to be 0, and 0 is less than the maximum possible error. So that means we should stop and we compute, or we print out the root of the equation. So therefore the root is, we now write this to 3 decimal places because that is what the question required of us here. They want us to write it to 3 decimal places. So let's do the needful there. So therefore the root of the equation is 2. We are going to write this to 3 decimal places, 2.2893 dps. So this is where we stop for this part A. For part A, this is where we stop. Now we are going to part Roman numeral 2, where we find the equation which is being solved by the iterative formula. We know that this is our beta root, but it was previously x, because if we were given f of x, which is equal to 0, we went ahead and we just made x the subject. So we are going to just replace back the x here, x here, x here, and then we cross multiply there. So we shall have x replacing xn plus 1 being equal to third into bracket 2x power 3 plus 12 all over x power 2. Then we go ahead, Roman numeral 2. We go ahead and we simplify. We come up with an equation. So we shall have to get here. So x here is equal to 2x power 3 plus 12 divided by 3x squared. So we cross multiply, we shall have this multiplying that, and we shall have 3x power 3 being equal to 2x power 3 plus 12. So collecting like terms, we shall have to get this coming this side. We shall have 3x power 3 minus 2x power 3 minus 12 giving us 0. So when we subtract there, we shall have to get x power 3 minus 12 equal to 0, and this here is the equation that is being solved. Thank you very much for being part of the audience for today's lesson. Keep on sharing, keep on subscribing, and recommending to your friends. Before we stop the lesson, I have prepared one question for you, which you are going to use this knowledge here, simplify, and you concretize the mathematics. So this here is our tryout question. Everyone, please endeavor to try it out, and see you in the next lesson. Don't forget to subscribe. Have a good day.